Hello again. The second part of this section is bodies and contact. So the purpose is to teach you some application, and the steps are similar, but the application probably needs some attention. Let's consider two bodies in contact without any slipping, meaning that there is no relative uh, position movement between bodies in contact. Consider two gears, C and B. We know the contact A between the two teeth from C and B. It's a common point. Therefore, it must have, this point does have tangential velocity, which is common for both of them. So we expect that tangential velocity of point A, dA, as seen by C, is equal to the tangential velocity of A as seen by B. Now, when it comes to the acceleration we said for an object or for a point in an object rotating about a fixed axis like this one, it does have two components, a tangential component, tangent to the path, and a normal one. Now, since the tangent acceleration represent the rate of change of the velocity tangent with respect to time, then it must be equal for both sides, C and B. So therefore, the tangential acceleration of point A, as seen from left side or right side, they are equal. And we know that tangential is equal to alpha multiplied or cross of RB, as seen of B, and from the right side is alpha, the angular acceleration, multiplied by RC. Now that's in magnitude. However, the normal component, which is AN, pointing from looking at point A from B side, so it's directed toward the B, and if from C side, directed towards C. These two components are different and not equal, simply because normal component, we know it's omega square r, where r and omega are different, would be different. Another common type of problems found in dynamics is rolling motion without slip. Example of that is a vehicle wheel rolling on a road without slippage, meaning that the contact point between the wheel and the ground is common, where the velocity of the point seen by the wheel is same as the velocity of the ground, which we know the ground is not moving, therefore it's both of them are having zero velocity or zero absolute velocity. However, because this is rolling, we can calculate the velocity of g, and that can be used relative velocity analysis, motion analysis, or IC, the instantaneous center of zero velocity. Let's calculate the velocity of g. Since this is IC, then therefore the velocity of g with respect to A is look like a simple rotation, so it's equal to omega as a magnitude, and if this is counterclockwise or clockwise, so it's a negative omega k cross rg with respect to A, which is this vector from A to G, which is, in this example, is rj. And that's going to give us a velocity vj, vg. And vg is simply going to be omega ri. Now, the question is, what is the velocity, what's the acceleration of g and acceleration of point A? Well, the method followed here is quite similar. We think that g is a point that is only translating, therefore we know it's only translating in the eye because it's not rolling. It's a point that doesn't roll. It just translate, or it doesn't rotate. Therefore, we know the direction of AG. So we know it's AG as a magnitude multiplied by the unit vector I. Also, we know that point A, it may not have tangential and normal. Now, a common sense will say, since the ground is shared and the acceleration of the ground is zero, therefore at contact, the tangential acceleration of point A, as seen by the ground, is equal to the tangential component of the point A, as seen by the wheel. So therefore, the tangential component must be zero. Must be zero, as long as we're not slipping. So we know that point A, because it's rolling, it must have a normal. So let's put this together into more mathematical equation and to show you what does that mean. Vg is equal omega r, or omega ri in vector. Acceleration Ag is equal to, using the relative velocity analysis, AA plus the acceleration cross G as seen by A, so this vector G with respect to A, where Rj, G with respect to A, is simply Rj and Rj, and alpha, this is counterclockwise or clockwise, so it's a negative alpha k, and the acceleration at A, it's simply in the direction of y, because we said the point doesn't slip A, so there's no component in horizontal, so it should be in the upward, and that's absolute. So we gave it an AAJ. So we want to compute how much is that acceleration, AA, or the acceleration at A. So that's a vector equation. After the conducted cross product, you'll find simply that the center has an alpha r and the contact only a normal omega square r. Or in vector space, alpha ri is ag, and at contact you have a normal going toward the g. Alright, let's take this example and conclude the lecture. We have a gear is rolling on a fixed track. The gear with the center O, there's a cylinder that is being pushed, and the gear is rolling at an angular velocity of 12 radian per second and angular acceleration of 6 radian per second square. We want to calculate the acceleration of point A. Now point A is not on the contact, is in the opposite side. So what's the plan? Now I can calculate the acceleration of A as seen by O, so using the relative motion analysis of the acceleration. So acceleration of A equal acceleration of O plus alpha cross RA with respect to O minus omega square multiplied by RA as of O. So what we need to find is how much is AO. AO from previous discussion is simply equal to alpha, or this is negative 6k cross r, where r is going to be, or across j, which is distance from here to here, which is 0.3 j. That's going to give us a tangential component AJ, or AO, which is, we can say it's 6 by 0.3 in I direction, and it's obvious if x is positive to the right. So we know AO, so as seen here, and that's an I. And then we calculate the relative or the absolute acceleration of O, or A, from the O, where RAO is position of A as seen by O, so it's from here to there, so it's 0.3 J. Alpha is negative 6K, and upon cross product you end up with that AO, or acceleration of A. So try solve this again at home and see if you get the result. So with this I conclude the lecture. There is a couple of concept quizzes. The answer for the first one is B. The answer for the second one is A. You try it at home. There's also problem solving. So try to solve it and compare your results with the solution. It's becoming much more involved in the cross product, but the concept is simple. And with this, I think we finished chapter 16. I will see you next lecture.